have to trust in something. Your gut, destiny, life, karma, whatever. Because believing that the dots will connect down the road will give you the confidence to follow your heart, even when it leads you off the well-worn path. And that will make all the difference. My second story is about love and loss. I found what I loved to do, and then I got fired. I really didn't know what to do for a few months.
Are you like ice, or are you like water? Ice breaks, water flows around, is everywhere, finds a place to go and rest. Soothing. Ice has stopped ages. Sometimes you can get bleeding from ice. So how are you going to be tonight? I hope so. Let me see if you are. So the page I put there, this is the way I would start for your exam. Make sure you review all your notes, which means you make sure that you review everything that's covered in lecture. After you do that, you read everything that's in the reader, plus all the problems in the reader. Then, make sure before you come to the exam, you go and read really well these pages from the reader. And then if you have time, you hear the review. Kindly, one of your schoolmates, one student of my Chem 2A class, Azeem, from the Chem 2A class, again, is videotaping your review session. Okay? And this time, since it's Tuesday, she's going to be able to do it by the end of tomorrow, I believe, by tomorrow night, even perhaps even earlier. But you still have a couple of days to watch the review if you want, or anybody who didn't come today, because other time was just 2 hours before or something. So, thanks to Azeem who's doing it for you. Again, second time. Yeah? He's there in the back. See him? So when you see Azeem on the road, you can say, Azeem, I appreciate what you're doing. Thank you very much. Will you say that to him when you see him on the road? Because if you do, he's not going to gain anything from you by saying that, but you will gain something. Because it will remind to you that unless you start doing selfless service, not thinking for yourself, but others, then you will truly make better grades and you will land a very good job. You will just sort of in life. So, do it for your own sakes, not for Azeem's sake. He has the time, the peace, happiness to do this for you. But if you feel frustrated and you are thinking only about grades, then you need to say thank you, because that way it will start trigger something inside you, and you will become much more successful at the end. So, you got the page down, right? Okay, and then if you have time, of course, you should go and read any text you like. Read text. If you have time, right? But you know there's not much time left, so this is the order of things. You do the review that we have on practice review, right? Practice exam online, and some videos. There's also videos there, old videos for review, correct? So you got a lot of things to do. I don't think there is enough time to do much more than that. And then you're covered. Like I said, the format of the exam is different. It will be no multiple choice like part 1, multiple choice is not going to be there. The emphasis is to explain things. Explain why, please, okay? A lot of things explain. And don't write a lot, because then you won't have time to finish. If you really know the explanation, you just throw a few words there, one, two lines, and then the day will know you really know it. Okay? If you don't know it, you might write half a page and try to show that you know it. It's not working that way. If you truly know, you know it, you understand it, not just making guesses. Just put the 3 words that they relate, the concept that they relate to it, and then you will get the point. Otherwise, you might write half a page and say, but look, but what? No. The half page shows that if you read it, you really don't understand. Okay? So, the pages are there. Read them very well. Not just memorize them. Understand everything that is in these pages and the lecture material. And then you will do fine. And again, it doesn't really matter. That's a tiny thing of your life. When you realize it, that's called kind of meditation. Realize this. It's just a little part of your life. Almost nothing there. When you don't realize it, then you will be anxious and you will not do well. So realize this. It's a very little thing. It does not really tell the world who you are and what you can do. Okay? I tried to put Steve Jobs' 3-minute thing because Azeem did 3-minute, the most important stuff, but it would not be working. So maybe on the break I can do it. He's telling us how he did it to be successful, right? Okay, so the first problem I'm going to be looking for is this one here. I think we're going to do the A first. Yeah, let's do it. Okay? We have done something like this, if I remember well, in the lecture, right? Remember? So, try it. Take half a minute to do it. It doesn't take more than half a minute, maybe less. Half a minute. It might be a different way, the problem given to you, to say how the rate depends on changing different concentrations of reactants. Instead of giving you that simplified, this is a simple version. It could be a little bit more complicated. Because the rate doubles when you double the concentration of A, and becomes 4 times bigger when you double the concentration of B, blah, blah, right? And then you figure out the rate law by doubling. This one is really, is giving to you already, the overall, it's already there. Okay? So either way, this is to solve it. I think we did it that way that I'm answering now in the lecture, yes? Did we? You remember? The example we did was a little bit harder than this. Yes? How many people remember? Let me see your hand. Okay, some people remember it. Okay. So, how are you going to do this, we said? How many people want me to do this problem? Maybe it's too easy for you. Let me see your hand. How many people want me to do it? So, what do? You want the units of the rate constant for a reaction, for the rate law of a reaction, when the overall order of the reaction is 3/2, right? So, that means that you can say the rate of the reaction is equal to the rate constant times concentration, this. It really doesn't matter. This can be A, B, C, D, right? Many. But the sum of the exponents will be 3.5. So it really doesn't matter. By having it detailed or like this, it doesn't matter. Okay? So now, you will find out the units of K. Well, you have to know the units of here and the units of there. Is that right? So, the unit of rate is always what? Concentration divided by time, and usually is what? Molarity per second. And so, A is always molarity, and that will be to what? To 3.5. And from here, what are you going to have? You'll have K is equal to M minus 3.5 times molarity times second minus 1. And that will give you molarity minus 1/2 times second minus 1. Okay? That's an algebra problem, really. It's not a chemistry problem. This is an algebra middle school problem, if we're going to be honest with ourselves. Right? Okay. Done with this? Okay. Now let's do a different one. Let's do number 9. Start working on it. I'll give you a few minutes to just warm up and start, okay? If I start doing it and you do not know yet the questions and what the problem is giving you, we're wasting a lot of energy and time. So make sure you concentrate on the problem, know what the problem is giving you and what the problem is asking you. Write down the equations, the symbols, and be ready to do it together. That's the way you will get most of it out. Get most that you can get out of it. Very important when you solve this type of problems to write down what the problem is giving you and what the problem is asking you in a form of equations and symbols. If you do that, 70% of the problem is solved. If you don't do that and you're just looking at the problem, it's not going to be solved. It shows you're tired. Take a nap or something. Because if you cannot write down things, right, it means that your mind is tired. You just don't feel like doing it. Well, it's not working that way. In order to solve the problem. Okay, so the first thing you want to do is write down what we know about this problem and what the problem is asking us to find. Okay, so there we go. So it's giving us the rate constant, right? Rate constant 5.0 times 10 to minus 5, second minus 1. But I have it in the problem. No, write it down. You have to write it down. There is a reason for it. Don't say it's in the problem. You don't have to write it down. Write it down. Okay, rate constant. Then it gives you concentration of this. Because by seeing together, without words, right, these things, immediately the equations come to your mind and you can see the solution in your mind. If you see words, reading the problem continuously, again and again, it's not working. That's why it's important to do this work that your teacher is doing it, right? Okay, this is the way. And he tells you at time t is equal to 1 hour. What is the concentration at that, what is the rate of the reaction at that time? Okay? So, okay, so how are we going to start? There's too many things that's giving me here, I'm getting dizzy. So what I'm going to go is, I'm going to go to what he's asking me. Okay, so he's asking me this, okay, if this is what I want to find, the rate at time t, then that rate is going to be equal to, the rate law will be equal to the rate constant times what? Concentrations of the reactants at time t. So I'm going to put it down unless I know the rate law. Do I know the rate law? It says, according to the first rate law, okay, so it talks about only one substance, right? And it talks about first rate law. Okay, you already know. So that's going to be A, and that's it. It says first order, so it's 1 here. It's not 2 or 3, 1. And 1 reactant. So read the problem carefully. The rate at time t is going to be equal to the rate constant times the concentration at that time t. All right. So I know this. I know this. And the only thing I need to know is this to be able to find what I need to find. Okay? So you can see that we need to find the concentration time t when we know the time and the concentration at the beginning of the reaction. So then you go to what rate law? The integrated rate law, right? Which gives the dependence of the concentration time t as a function of time. Yes? If you know the initial concentration. So you go and find out from the end of the last page of your exam the equation that relates to the first order. On the last page of your exam, the equations are going to be there, but they're not going to tell you this is for first order, this is for second order, this is for third order. So you're going to have to know which equation corresponds to what order. Yes? Okay. So if you go there and find out for first order reaction, the integrated, this is a differential, and we said why it's called differential. The integrated rate law of first order reaction is going to be natural log of concentration time t is equal to minus kT plus natural log of the initial concentration. Yes? And so now, you know this, you know this, you know this, and you can find that. Do you agree with that? And if we find that, then you know then you know the rate of time t. So the only thing we have to do is to just substitute the values here. Again, that's a middle school problem. Natural log of what? A, the time t is going to be equal to k minus k now it contains seconds, so I better put the time in seconds, not hours. If I want the units to go away, I better put it in seconds, right? This is what? Second minus 1. Plus natural log of 1. So if you do the calculation, you find out it's minus 1.8 times 10 to minus 1. And from here, if you use your calculator correctly, then you will find out the concentration time t is going to be this one here. And if you put that one into your first equation, the rate of time t will be this one here. Equal to 4.2 times 10 to minus 5 molarity per second. Right? Yes.
Should it be 3,600 seconds?
3,000? What did I put?
36,000.
Oh, 36,000?
10 hours.
And 4 hours?
7 hours, right?
1 hour. Yeah, so how much is 1 hour?
3,600.
Yeah. Should be, as you said. And do you get the same number? Did you get 0.8335 if I put it this way, correctly? Yeah? Okay. Even taking into account the correction. Okay. Thanks for telling me. How many people there to do it? They expect somebody else to do it. Two obstacles for becoming successful. Shy and closed mind. Shy and closed mind will not help us to succeed. Okay, let's go to the next question. Let's next problem. Let's do number 11. When I said multiple choice, I meant multiple choice concept, not short calculation. You will have about, I think if I remember well, 3 only problems like the one that we did just now. 3 multiple choice, doing calculations like this. That's it. And then the other ones, instead multiple choice concept is going to be different things to explain, and then part 3 is going to be similar things. You know. Again, explain things. Take a ride. Enjoy the scene. Sometimes we go into a bus and we say, is this driver okay? Does he have a license? Is he drunk? Did you put enough air in the tires? Did you do this? Did you do that? When we start driving, we still have the same questions. I think this driver is not driving really good. I think he's absent-minded, or she's absent-minded. Oh, the streets are not good. Something's going to happen. My gosh, what's coming up? We're going to crash. And we are not enjoying the trip. And we don't realize in the same bus there is 30, 40 people, and very few, maybe 2 or 3 or 4 in the bus are continuously tormenting themselves with all kinds of questions. We need to realize why are we doing it. Whatever the exam is, for every class you're taking, chemistry, philosophy, it doesn't matter. Whatever the exam is not just for you. It's for everybody. If the exam is hard, it's exam hard for everybody. If the exam is wrong in some parts, it's for everybody. So don't worry. It comes up to the same denominator. Why don't you just relax? Take the ride. See how it's going to be the next day. Try it. Release. Release that anguish. Just drop your suitcases. When you take a trip in the train, you're holding your suitcases like this. Not just like that, like this. Just drop them down. Take the ride. Enjoy the trip. Okay? Are you ready? Did you do the same thing again to put things down? Let's do it. The rate law of a reaction is this, okay? And its rate is, you know the rate constant, right? Okay? If we double the initial concentration of the C reactant, then the initial rate of the reaction is. Well, if you're looking at the rate law, right? We know that if we double the concentration, or if we change the concentrations of A and B, somehow we know what happens to the rate, right? Because we know the exponent, yes? We cannot say what happens to the rate if we double the concentration of C because we do not know X. If X was 1 and you double it, then the rate will double. If X was 2 and you double the concentration of C, then the rate will become 4 times larger. Yes? But I do not know X, so I cannot answer the question. I have to find X. How are you going to find X? That's a good problem, actually. Tupa's making. When you like math, when you're in high school, then it spills out when you teach chemistry. Come on, really. There's no chemistry. So how are you going to find x? It's the reverse of what we're doing in the previous problem. You remember what we did in the previous problem? We knew the exponents, and we found out the units of k, yes? Well, now, you know all units, because you know the rate constant. So you know the units. You know the units of rate, you know the units of rate constant. You know the rate law depends on this concentration, so you know the units for every one of them. So you know the units in both sides. Maybe I can use that to find x. What do you think about that? Why? Because the units have to be the same in both sides, doesn't it? X has to be such a number that the units must be the same in both sides. And I know the units on the left, the x has to have such a value that the units will be the same on the right as they are in the left. Is that right? And in that kind of thinking, we can find x. Yes? So let's start making the units appear in the rate law. Make the unit appear. So what do you do for that? I don't want to write it again. It's the same thing exactly. And rate is going to be what? Molarity times second minus 1. And then we have what? K. What does it? I don't need the number, I just need the units, right? We're working on the units. Will be what? Molarity minus 1/2 times second minus 1. And then we have A to 1/2, that's molarity 1/2. And then we have to molarity minus 1, and then we have molarity to x. Do you agree with that? You will not find these problems anywhere. Why? Because this is creation. When you love something, you create something new. And then you're proud of it. You look at it and say, this is not anywhere else, as far as I know. Why? Because when you love something, you create something new. So what are you going to do outside there? Are you going to copy people? To do exactly what they do? You will never be happy. Why? Because you're creators. There's something inside you that cries to create. And if you do not create, you will always be unhappy. Because you go against your own nature. So let's get it together, right? N s minus 1 is equal to... First of all, you see that this goes away with it, yes? And then you have molarity is equal to, if you put all these together, right? Minus 1/2 plus 1/2 minus 1, that's minus 1. So it's molarity minus 1 times molarity x. Okay? And this is molarity to x minus 1. This is the same thing like this. So really you come up with molarity is equal to molarity x minus 1. This is 1 there. When you have two numbers the same, this is like an elementary school, middle school algebra. When you have two numbers the same and the base is the same, the exponents are the same. Yes? X is equal to 2. And because X is equal to 2, if you double the concentration of C, the rate will become 4 times bigger. Everybody got it? See? Yes? Any question? Why would you do this? Why would you do that? No? Done? Okay, let's go to the next. Here is a good one. Fresh one. It was given actually for 2010. But that's again, something new. You create things. Why? Because you are creators. You don't allow yourself to do it because you want to live the life of others. You want to live the life of others. Because you say, I'm going to make them happy. And you are unhappy. How can you make people happy if you are not yourself happy? How can you do that? You cannot do it. So you've got to live the lives of other people. And then, how can you create new stuff? You don't have the joy. You don't have the bliss to create. You're not creating new stuff. You're dead. We are dead when we don't create because we go against our nature. Yes? You don't believe it? How many people believe it? Let me see your hands. Let me see your hands. How many people believe it? See? There are some of them that are very busy. The ones that are so busy to answer this question to the teacher, they will have to do a lot of work to stop the sorrow. Because they're so stuck. So stuck to make other people happy. To follow preconceptions and ideas of other people. And conclusions of other people's opinions. So we think we can do it by just passing the class or graduating from college. No, it's not going to happen. Many people graduate from colleges. Very few are very truly successful and happy, and everybody can be a successful and happy. Very few people are. Why? Because we are looking at the wrong direction, trying to satisfy and make people happy when we are not ourselves happy. No? Yes? Okay, are you ready? Okay, this is kind of a peculiar problem, isn't it? Very interesting, I'll show you. Okay, like I said, this is new stuff. Okay, well, what do we want to find out? We want to find out the concentration of initial concentration of B, yes? So we are looking at initial concentration of B, how much it is. And we have a diagram. The diagram can give us something there. What does it give us? We know that we have a tangent of the curve that shows the concentration change is a function of time for reactant A at time is equal to 0. That means that we have a what? Initial what? What is the slope? How much is the slope? What's the volume of the slope? Anybody? It says to you that this angle is 45 degrees. Yes? 45 degrees, can you see it? Okay, somebody said the slope is positive 1. Okay. And that is, the slope represents what we said? Of the tangent represents what? The initial rate at time, the initial rate, which means the rate of the reaction at time t is equal to 0, yes? Okay, so really this diagram, what it's telling us is that the initial rate of the reaction is 1 m times second minus 1. That's what you get from the diagram, and then we get the diagram. Instead the problem is giving you that, it keeps showing you the diagram, okay? You like this problem? I love it. It's a really great problem. Okay, so you know this. Now, what do you want to find out? From this one, you want to find out this. Well, how does R initial relate with initial B? That will relate with what kind of equation? The rate law, yes? The differential rate law, is that right? So the rate initial, I have to find a relation between the two to find this one from that one. The initial rate is going to be equal to the rate constant times, what else? There's one reactant. Initial there, initial there. One reactant, so I put a B there. What's the order? I don't know what the order is. Do I? The problem does it give us? Huh? Yes? Who says yes? How? You remember? That was made in a note during lecture, right? How do we know that? Units. From the units. So what's the order? Okay, it's a second order from the units. From the units of K, if you don't remember it, then you will have to do the work we did for another problem before and find out if the rate is equal to 2. But if you remember, then you know it's 2. Okay, so from that, we know that it's second order. Okay, well, you're ready to go. You already solved the problem, didn't you? This is 1. The rate constant is 0.25. And you have square. I did it on purpose that way, so you don't have to worry about numbers. And you solve it very easily. You have your calculator just by thinking about it. So that will be 2n. Isn't that true? It's a true problem. All right, let's do some problems that they don't have numbers. How about that? What do you like? Problems with numbers or without numbers? Huh? Conceptual? How many people like conceptual instead of numbers? Raise your hand. How about numbers? How about numbers? Numbers. Oh, okay, that's good. Let's do conceptually, huh?